Prof, it's for everybody. We haven't been able to sort it out, so we'll just cut it off.
Okay. I think what I was trying to point out is that what I'm seeing on my screen is, is the audience. And the shared screen is on a small, I don't know whether maybe it's the way I have configured my, but anyway, I would like to welcome you all to this presentation today. And I think Harold has been doing this for more than a year now, introducing the night skies in Botswana. But then today he has agreed that he will do the this talk, which is about time as a common denominator. So as I said, Harold needs no introduction, but he does have a biography which suggests that his first love is really cricket, and he is together with Geraldine, his wife, now an enthusiast of the night sky. So we are going to hear about that and how now time is this common denominator. I think I'll let the speaker start, but as I said, I think we still have an issue with the screen because I see the audience on my main screen. Harold, I think you can start.
Okay. Thank you, Prof. Thanks for the introduction. Good evening, ladies and gentlemen. My apologies that the screen seems to have been cut off on the right-hand side, but as we go through it, I'll try and make up for that. So we're going to talk about time. Time describes the distance between the stars and also time, our history. So without further ado, let's go in. I'm showing here a slide of a solar eclipse, and it shows the light coming from the sun, from behind the moon. It's a form of electromagnetic radiation, and you can see it's a very powerful agent. Just as a matter of interest, there's a solar eclipse in the United States in April the 8th. And if anybody has never experienced a total solar eclipse, I thoroughly recommend they make every effort to experience it. It is something just incredible, and it's free. You've just got to get there. The next solar eclipse in Botswana and South Africa is on my sister's birthday, her 87th birthday, so she'll still be quite young, on the 25th of November, 2030, and then on the 8th of February, 2046. I'll then be 106. I'll just have a little problem of moving from my wheelchair into my Land Rover. But otherwise, I'm looking forward to the 2046 solar eclipse. Right, the speed of light is given in a number of dimensions, sometimes 299 million meters per second, 300,000 kilometers per second. For me, the most meaningful one is 186,000 miles per second. But I find that very difficult to conceptualize. So as the circumference of the Earth is 26,000 miles, it means that light travels round the Earth 7 times in 1 second. That for me is easier to think of than 186,000 miles per second. We went to Panama over Christmas and New Year, and it took us 24 hours flying time to get to Panama City, which is halfway around the world. So we did in 24 hours what light can do in 1/14 of a second. So when you think of the speed of light, think of light traveling around the world in 7 times in 1 second. Not 7 seconds once, but 7 times in 1 second. And that's meaningful to describe what I'm going to be telling you tonight. So how far away are stars, star clusters, nebulae, and galaxies? We normally talk about them in light years because it's when you think of light traveling 7 times around the world, think of how far it would go in a light year. And that's how we conceptualize it. So if we say a star is 10 light years away, it means light takes 10 years to get here. So then what I found easy is you look at some item in the sky, see how far it is in light years, and then think what was happening on Earth that time away, and then you can conceptualize how far away that star or galaxy is in terms of time that's elapsed. I hope you're all with me. So we're going to try and concentrate on the stars and the galaxies and how far away they are and how much time has elapsed on Earth since light left those objects. I hope that that's come through. Before we start, we get our bearings. That's if you go into your garden and look south, and then you look up tonight at 10 o'clock, that's what you will see if you have a clear sky. The main thing to look for is the Milky Way. That's the light white going through the middle. The ecliptic is right on the edge, but it's behind, because we're looking south, it's behind us. You know the ecliptic is the imaginary line followed by the sun, moon, and the planets during the day and night. Then let's look at some of the major items to get our bearings. If you look into the Milky Way, in the middle you can see crux, 4 bright stars. That crux means Southern Cross. And then you can see below it the 2 pointers. There it's called Rigel, Centaurus, and Hadar. That's, in other words, Alpha Centaurus and Beta Centaurus. And if you follow, I don't know if you can see my pointer going round there, that's Centaurus going round, and then up here. While we're at Centaurus, tonight I'm going to be talking later, talking about Omega Centaurus over there, which is a massive globular cluster. Then we're going to be looking at later Eta Carina Nebula, that's over there, just to the right of Crux. Then further to the right, much further, is Canopus, which is the major star or the brightest star in Carina, the galaxy called, the constellation called Carina. We're going to go further across, and the brightest star in the night sky is Sirius. That's in Canis Major, Sirius. Then we're going to go to see the main summer constellation is Orion with Betelgeuse and the nebula there. And that's enough to get started, because otherwise I'm going to confuse you. And right below here is Achernar. We'll deal with Achernar as well. Yeah, it's a large Magellanic Cloud and the small Magellanic Cloud. And all these items I've mentioned are quite prominent in the night sky, in a darkened night sky. You won't see them from the city. You have to go out into the bush, far away from the city, and then you'll see them very clearly. So you've got your bearings. You see the Milky Way and these major items I've seen. So let's start. So here I've shown 2 bright stars. On the left is Alpha Centaurus and the right Beta Centaurus. Those are the 2 pointers for the Southern Cross. Alpha on the left, Beta Centaurus on the right. I don't know if you can see, almost below and to the right of Alpha Centaurus is a little pink red dot, and that is Proxima Centauri. Now, Proxima Centauri is the closest star to the sun or the earth or the solar system. That little red bit there, can you see it there? There. That's the closest star. Now, Alpha Centaurus, that's that one, is 4.6 light years away, and Proxima Centauri is 4.2 light years away. Now, when I say it like that, it actually doesn't mean anything. How far away are they? So just think of light traveling 7 times around the world in 1 second. Extrapolate that to a minute, to an hour, to a day, to a year, to a number of years, 4.2 years. So what happened 4.2 years ago when light when you're seeing Proxima Centauri, that light left that star 4.2 years ago. So what happened then? Well, that was the outbreak of COVID. So if you can think back to when COVID first appeared on the scene, the light left Proxima Centauri then when that broke. The one on the right, that one's dealing with Alpha Centaurus, and that shows Owen Farrell of England grabbing at shadows. He's missing Colby, and Colby's leading to winning the World Cup for South Africa in 2019. So that gives you an idea of how far, when we won the World Cup in 2019, the light left Alpha Centauri. So I think you're getting my drift. So I'm going to carry on in that view. Sirius in Canis Major, I told you, is the brightest star in the night sky. If you go out, it's easily to see the brightest star, and it's not far from Orion. And that is 8.7 light years away. So what happened 8.7 years ago? So let's have a look. Brexit. Theresa May was appointed Prime Minister in England. Donald Trump won the election in 2016 in the States and became president. So when those things happened on Earth, the light that you're seeing at Sirius left the star then. That's how far away, traveling at 7 times around the world in 1 second. So light left then when those incidents happened on Earth. Let's look a little bit more. Astronomy. This is the least spherical star in the Milky Way because the horizontal dimension is 35% larger than the vertical dimension because it's spinning so quickly. It's the brightest star in Eridanus, and I've shown a little map of where Astronomy is. It's to the right below the SMC is Small Magellanic Cloud, and below the Large Magellanic Cloud. So Astronomy is 139 light years away. We say it quickly, we actually don't think how far is 139 light years. Light has been traveling at that speed for 139 years. How far away? Well, the first day of Test cricket ever was 15th of March, 1877, almost exactly the same time as light left Astronomy. But that doesn't mean much to you. So let's look at the Boer War. Boer War, this was 22 years before the outbreak of the Boer War. Light left Astronomy. So you can go and see it. If you look at the Astronomy tonight, you can think back to the Boer War, because that's when light left there. The Boer War was on the go when the light left Astronomy. So let's carry on with this theme. Canopus in Carina. I did point out Canopus to you. It's to the far right of Carina. And I've got an inset down below on the left-hand side, which shows you Crux right on the left. And then you go across to Carina and then Canopus. It's a major star in Carina. And that is 310 light years away. So what happened in 1710? Well, the typewriter was invented. The piano was invented. The thermometer was invented. All those inventions took place at the same time that light left Canopus in Carina. Now, I spoke about Orion. Orion is the summer constellation. Orion is the summer, and I think you all know the winter constellation is Scorpius. Now, at this time of the year, at about 10 o'clock at night, is about the only time in the year, well, once or twice, that you can see both Orion and Scorpius. Orion is setting in the west and Scorpius is rising in the east. Now, I want to deal with Betelgeuse. Betelgeuse is the second largest star in the Milky Way, that one there, the bright star. It's the second largest. If you put our sun in the middle of Betelgeuse, then Mercury, Venus, and the Earth would all rotate around the sun, but we would be inside the outer circumference of Betelgeuse. That's how big it is. And Betelgeuse, the light is very bright. It's 542 light years away. 542 years ago, light left Betelgeuse to arrive here now. So what happened in 1480? Oh, hang on, I've missed one. I must have taken it out. I've missed it, must have gone out. Well, 542 years away was 80 years before Galileo and Shakespeare were born. Before they were born, Galileo was born in 1560, and you all know that he was put under house arrest the last 10 years of his life because he said that the earth moves around the sun. Before that, everyone thought that the sun moved around the earth, but it was against the teachings of the church. So he was put under house arrest by the Pope for being so blasphemous. Right, Orion Nebula. There's Orion. There's the nebula, Orion there. It's 1,300 light years distance and is the closest region of massive star formation to Earth. So you look at the sheath or the sword of Orion, and that's the nebula. It's a little fuzzy dot. And what happened 1,300 years ago? Well, the Battle of Hastings was about 1,200 years ago. No, sorry, 1,000 years ago. So this was 300 years before the Battle of Hastings. Why did I pick on the Battle of Hastings? Because in my book, that was the first sort of incident that happened in modern history. It was the fight between the Normans of France and King Harold of England. And poor old King Harold, he's lying there with a sword piercing him. So there's King Harold lying, and there is the Normans holding their hands aloft. They were holding the spear, and they've won that Battle of Hastings. And the light that we're seeing from Betelgeuse, at least from the Orion Nebula, left 300 years before that incident. Eta Carina Nebula. Now, I've mentioned Carina, but there's a nebula in Carina at the far left side, and I'll try and go to this inset. I hope you can see my little pointer. Eta Carina is here, there. It's just above southern Pleiades. There's the false cross. There's Canopus. We've mentioned Canopus, and there's Crux. So there's Eta Carina. Eta Carina is 7,500 light years away. How far is that? Well, the first wheel invented by man was the potter's wheel, and that was 4,500 BC, so that's 6,500 years ago. And Eta Carina light left 7,500, so 1,000 years before the potter's wheel was invented. As a matter of interest, it took man another 1,200 years to invent wheels for vehicles. After they had the potter's wheel in front of them, it took them another 1,200 years to invent wheels for vehicles. And then they took another 1,100 years to domesticate the horse to pull the vehicle. So Eta Carina, the light from there goes back a long, long way, even before our first ever decent invention. Right, let's talk about Omega Centauri. I did point out Omega Centauri. It's in Centaurus, and it's a globular cluster in that constellation. It was first found by Halley in 1677, and it's the largest known globular cluster in the Milky Way. It's a diameter of roughly 150 light years. So light takes 150 years to travel from the left-hand side of that picture to the right-hand side, 150. But it takes 17,000 years to get from that picture to us. What happened 17,000 years? Well, if you look on the left side, Africa, the first humans were here about 200,000 years ago, and they spent about 100,000 years wandering around Africa, getting involved. Then they moved up to Europe, then slowly drifted across to Asia and down to Australia 40,000 years ago. Across Asia 20 to 30,000 years ago, then 12 to 15 to get to the Bering Strait and Vladivostok, across to America, 12,000 years ago, and then down to South America, 10 to 11,000. So man hadn't reached North America by the time when light left Omega Centaurus. Some say man should never have got there, but you didn't hear me say that. But man only reached North America 12,000 years ago. And I find that incredible. So that's how far Omega Centaurus is. And you can see it easily with binoculars, but you sometimes maybe see it on a clear night on a dark sky with a naked eye. The next slide is another depiction of what I've been talking about, but I prefer the other one. And now we go to the Tarantula Nebula, first seen by de la Caille, a Frenchman who climbed up Table Mountain in 1751. Can you imagine climbing up with a scope up Table Mountain? There were probably lions around, things like that. And he had some porters carrying his equipment. 1751, and he looked around and he saw the Tarantula Nebula and about 10 different constellations which had never been seen from the Northern Hemisphere. So if there's quite a good sentence here, this is an extremely luminous non-stellar object. Its luminosity is so great that if it were as close to Earth as the Orion Nebula, the Tarantula Nebula would cast visible shadows. Now, it's 169,000 light years away, near the Large Magellanic Cloud. What was happening then? Well, we were all living in caves. So when our forebears were in caves, light left Tarantula Nebula. And you can see it quite also again with binoculars. Just have a look at the Large Magellanic Cloud just to the left. You'll see that. So let's talk about Andromeda Galaxy, which is the closest galaxy to our Milky Way galaxy. It's 2.5 million light years away, but it's traveling at about 250,000 light years towards us. I don't think I've got that right. No, I haven't got that right. So, that's not it. That's 2.5 million light years away, and we're going to collide with Andromeda in 4 billion years' time. Sadly, Andromeda is much bigger than us. It's got 1 trillion stars, and we've only got 300 billion. So Andromeda will dominate us. But fortunately, there's such a great distance between all the different stars in these galaxies that none of them will collide. But I can safely say that nobody listening to this presentation will be around then. So don't worry about it too much. Lake Makgadikgadi was full from 2 million BC to 8,000 BC. And so if we go back, the Andromeda, we said, is 2.5 million light years away. So that reached here just before the Makgadikgadi was filled. The Makgadikgadi was full for nearly 2 million years. So, and this is where man spent quite a lot of time growing and evolving. And I've seen some of the artifacts on the edges of the Makgadikgadi pans, where the early man lived for quite a long time. So that's Andromeda, 2.5 million years. This is the Virgo cluster of galaxies. If we take the top one there, M66 group, 35 million light years away. What happened then? Well, that was when the Great Rift Valley formed. And you can see the schisms in the Earth. You can see Lake Victoria, but you can see the Rift Valley. It's quite clear. And that happened 35 million years ago. And that was when the star clusters from Virgo, and I'll show you later where Virgo is. On the top left inset, you can see the Rift Valley. They've got a drawing of the Rift Valley in Africa. So it just shows how strong nature is. NG46. Now we don't even get to name these things. They just catalogued. It's all, it is named Umbrella Galaxy, 62 million light years away. Doesn't sound fast. Just say it quickly. 62 million light years. It doesn't mean a thing. But how long ago was that? It's located on the outskirts of the Virgo cluster of galaxies in the constellation Coma Berenice. So that's a timetable of the mass extinctions which have occurred over time. If you go to the left, you'll see the first peak on your left happened 460 million years ago. That's when 86% of the species in existence then died. Then we carried on until 360 million years ago. Then 75 species became extinct in that late Devonian extinction. Then we went to the next one, the third mass extinction at the end of the Permian age. 96% of species became extinct. Then the fourth one, the end of the Triassic, 80%. And then just recently, 65 million years ago, the end of the Cretaceous period, 76% species. It's rather, you must wonder about nature. When you see all these extinctions and you think about all the species we have here of animals, birds, trees, plants, reptiles, insects, fish, and only 1%, and these species represent less than 1% of the species that have ever been created. It makes one feel very humble. So this, we're talking about this galaxy occurred here during this time, 60 million years ago. That was the Umbrella Galaxy. That photograph was taken by Hubble. Then Hubble has noticed a fascinating galactic connection 200 million light years away. And this is called ARP 248, named after an astronomer, Hilton Arp, who published a book in 1966 of fascinating galaxies, which no one was paying attention to. And these galaxies are connected by a stream of stars, gas, and dust created as the galaxies tug on one another gravitationally. The tails are made of material from the outer spiral disks of the merging galaxies, and they host active star formation indicated by blue. So stars are being formed in these blue areas that you see between these interacting galaxies. Now, how long ago is 200 million years? I just want to show you where we are. That is in, I think I said in Coma Berenice. And Coma Berenice is, if you see, north is at the bottom, east is over there. So it's halfway between north and east. There's Coma Berenice. And I've spoken about Virgo, which is there. We're now looking north, as I said. So those galaxies I'm talking about are in Coma Berenice. What happened 200 million years ago? Well, that's when Madagascar started separating from Africa. It started with a big earthquake about 165 million years ago, and started drifting slowly, and then a severe earthquake, and it separates about 200 million years ago. That's when it started, 200 million years ago. Yeah, so that's Madagascar, 200 million years ago, and that was the galaxy, the Hubble, ARP 248. So next we go to ARP 220. That was 250 million years ago. Most of the energy output thought to be the result of a massive burst of star formation or starburst. And the merging of the two galaxies started about 700 million years ago, but that's shown 250. What happened then? Well, out of interest to people from Botswana, we had a very big eruption, volcanic eruption, 245 million years ago. And under high pressures and temperatures, diamonds were formed, and it eventually developed into the Zhuaneng pipe. And 200 million years ago, Europa was developed. That's quite recent, only 200 million years ago. So those are being mined now. They were formed, as I say, 245 and 200 million years ago. And that's when the light from this ARP galaxy came. You can't see this with binoculars. Sorry, you'd need a powerful telescope. The Coma Berenice galaxy cluster is one of the most populated galaxy clusters known. It contains as many as 10,000 or more galaxies. 10,000 galaxies. There are more individual galaxies in this cluster than there are stars visible to the unaided human eye on a clear, dark night. So, the center of this Coma Berenice cluster is about 320 million light years away. Say it quickly and it's not very far. But the cluster spans a distance in space of 20 million light years. So, light takes, to move from the left-hand side of this photograph to the right-hand side, takes 20 million light years. And the galaxy, this cluster is 320 million light years away. What was happening then? We're talking, yeah. So let's go here. Pangaea, all the continents were one 250 million years ago. But we're talking about this galaxy was 320 million years ago. So it was before Pangaea started to drift apart. 200 million years ago, 50 million years later, Pangaea broke up into two, what would you say? Continents, Laurasia and Gondwana. And you can see in Gondwana, there's India down there separating, and then this is Antarctica. And actually Gondwana at one stage was over the South Pole. Then from 200 million to 65 million, the continents have spread quite a bit. And you can see that Madagascar is now quite a bit away from Africa. But in this picture here, 200 million years ago, it was still part of Africa. Then 45 to 38 million years ago, just down the road, that's what we looked like. India is almost in position, Antarctica down there, and Australia there. So this galaxy I'm talking about was 320 million years ago, before any of this ever happened. That some artist has painted where all the countries are now, where they would have been if the continents hadn't separated. That's just a silly little thing. So that ends my story. I've pointed out quite a few features of the night sky to you and how far away they are. I just thought I'd spend a couple of minutes talking about, if you go out sometime during this next month, what you'll see. New moon is on the 10th of March. So that will be a very, very good time to go out into the bush, far away from wherever you live. If you live in the city, and have a look at the night sky, you'll be in awe of what you see, all the stars. Full moon is the 25th of March. That's when you definitely don't want to do any stargazing, unless you want to look at the moon. All the planets are clustered closely about the sun. It doesn't often happen, but it means you can't see most of them. You can see, before dawn, you can see Mars above Venus in the early part of the month in the east. Before dawn, Mars above Venus in the east. In the early evening, you can see Jupiter in the west, and all the other planets that I'm spoken about, that's Mercury, Mercury, Saturn, or the other one, Neptune, all of them are around the sun, so you won't see them. Then just to remind you, April the 8th is the total solar eclipse. It's not too late to book a flight to go to America and experience this total eclipse. It is something spectacular. And with that, I end my presentation. I'm prepared to take some questions. I'm not sure if I can answer them, but I'll see what I can do.
Thank you very much, Harold. That's very, very fascinating journey through history, geology, and everything. So I think at this point would, welcome questions. Oh,
No questions.
No questions. Yeah. Yeah, I think it was of special interest to me, because I tell you, when you enter geology classes, you don't believe what really is happening. But I think you have brought it to reality and clarity to many who really perhaps are not familiar of how vast time span can be. So to me, it was a very fascinating talk where you can actually relate what you see in the sky to the geological past. So if nobody else has thought of a question, I don't know, I'll give people to think about, maybe recover a little bit.
Prof, if I can say, I went through quite a lot of information. I'm hoping this was recorded and it should be on our website. So if they want to look for some of the details again, they can just go onto our website and see it. If it was recorded, I don't know.
It was recorded.
I can see the recording button is on, so yeah, I think it's definitely being recorded.
Okay.
So I think if there are no more questions at this juncture, I would very much like to thank Harold.
Oh,
and
there's a hand.
Hello.
Hello, no, good evening, Prof, and thank you for the nice presentation. I'm sure what the speaker was saying that what we see might not be what it is because we are very much, behind in terms of the picture. I'm sure this is also teasing you for the other listeners. What we are seeing, there might be other pictures, but we might not be around to see that because of the time span that he's been explaining. That's basically what you're saying.
Yeah.
I don't know if that joke makes sense.
Yeah, no, it's very fascinating. What we are seeing now, yeah, it's things which have happened in the very distant past. So, so I think without more questions, maybe people have still thinking about, because it's still dazzling. For a geology students, it takes a few weeks or even months to digest the vastness of time in the geological past. So I'm sure for everybody, it does take some time to really appreciate how the reality of time is more complex than what is apparent. So thank you very much for your listenership. I can see that we do have some international audience. Our monthly talks are every month, the last Thursday of the month. So we are looking forward to more over the coming year. So please look out for our website. These events are usually announced on the Astronomical Society of Botswana website. And as somebody has mentioned, you can also see the recordings of many of these talks on that website. So with that, thank you very much, Harold, and good night, everybody.
Good night. Thank you.
Thank you. Thank you. Bye.
Bye, Rob.
Thank you.
Thanks a lot. That was very good.